Okay, so now question 7. What are electron orbitals? So, what are electron orbitals? So, in this type of question, okay, electron orbitals, they used to actually be drawn like this. You know, you'd have your nucleus here, and then you have just like that. Those are your electron orbitals. But now we actually have a better grasp of it. So there is this, I believe it's not really, it's kind of like a equation in physics that they use, is that when you get closer to the location of the object, when you can pinpoint the location, you have a harder time. Yeah, when you pinpoint the location of an object that's, like, I guess, moving fast in space, your variable that gets bigger and bigger, as in that gets less accurate, is your time. So as you know more and more about where the object is, you know less about when it was there. Okay, and now vice versa. As you know more and more about when the object was there, you know less about where the object is. Okay, I do hope I'm explaining this right. It's a very weird equation, but that is what the constant is there. And the way it applies to electron orbitals is that now we know that they're more like this, where we have the nucleus still, and we still have a shell, as they call it now, because this is now the approximate place where an electron at this shell should be. That is now how we understand orbitals. And then if we drew one more out there, now in the second shell, we know that this is where electrons should be. And it kind of keeps going like that. Those are what you understand as orbitals. And there's also different types of, I guess, not coordinations, directionality, I guess, in terms of the orbitals, where they're, I guess, subshells. Yes, the different types of subshells, where they refer to, like, I guess, a spin and rotation and everything else. That one we won't get too deep into, but the concept you have to know is that, in a sense, in each subshell, there likes to be 2 electrons. So there's always going to be a pair of electrons in each subshell. So typically, actually, well, thoroughly, for the first subshell, it only, and the first shell, because the first shell only has 1 subshell, it only has 2 electrons in there. Where are they? We don't know. We just know that it's somewhere in that shell. That is what we know for the first subshell. Now, the second shell has, oh no, I erased the wrong one. The second shell, okay, that's what I'm trying to draw here, has 4 subshells. Okay, it has 4 subshells because in total it can fit 1, 2, 3, 4, 5, 6, 7, 8 electrons in it. Remember, each subshell is a pair, so you have 1, 2, 3, 4, and you start learning those later. So in a sense, the first subshell that comes in that gets filled usually is the S subshell, and then the next one are P, and S is only 1 subshell, and P has 3 subshells in it, and each one has 2 pairs of electrons in it, and it determines their rotation and everything else like that. But these also count as information about the electron orbitals. So electron orbitals, that is quite a big question, but the most important thing to understand is that they're the area where an electron should be present. Well, 2 electrons if it's full. Hydrogen is the only case really where in its first shell it only has one electron present, because they like to be in pairs when they can. But point being is that, let's say if we're looking at periodic table, if they asked for how many valence electrons were in silicon, valence electrons means that it's in its most outer orbital. Okay, and the way you figure that out is by noticing which group it's on the row, specifically for things that aren't transition metals, because those ones get really wonky. But silicon in this case, it's in row 14, so it has 4 in its valence shell. The reason why is because it has 4 more electrons than neon, and neon is right here, it's full. So, and if you notice, if I asked, yes, how many are in neon's valence shell, you wouldn't say 0, you would actually say it still has 8, because that's what a full shell is, at least in that area. So those are kind of just the full explanation of electron orbitals. It is quite a loaded thing, but hopefully they don't ask too deep into it. What they're referring to here is most likely, what does that mean? And you can simply put that's the space where the electrons are. And he specifically mentioned space and not like a line, because exactly like it's just in a sense a shell, if you think about it, where the electrons are roaming. Okay. And now question 8.